Hey, welcome back, guys. I just received an email from one of your colleagues asking me about the parallel multipliers. So basically, guys, multiplication is nothing except the fact that we are adding the multiplicants with the multipliers a number of times. Therefore, what we are doing here is we are converting the multiplication into an addition process. So if you remember at elementary school, calculate, in order to calculate 3 multiplied by 2, that's basically I'm adding 3 two times. So that's why I'm gonna get 6. Okay, so what we are doing here, we are doing the same. So basically we calculated the multiplication and we're gonna convert it to an additional process. Okay, so since this ANDed operation will not be added to anything, it will come by itself, and this will give you what? P0. That's why I can write P0. Okay, so basically that is A0 ANDed with B0. Okay, now in order to calculate P1, I have to add A1B0 with A0B1. So this is a 2-bit addition because at the end of the day, this can be like either 0 or 1, and this can be either 0 or 1. Okay? So to do that, we need a half adder. That's why I implemented a half adder between log to the operands here. It's A1B0 as well as it's A0B1. Okay? That's why that is P1. Now, this half adder will produce a carry, okay? And this carry will go somewhere here, okay? So at this point, what I have to do is to ripple that carry somewhere, and then these 2 bits can be added using half adder, like half an adder here, and then the carry from whatever I produced here can be added with the full adder with the sum and the carry from for this operation, okay, and so on. And this will give you what, guys? This will give you P2, and we repeat that. So at any given time we are breaking the addition operation into multiple additions. So we're adding this operand with this operand, and the resultant will add it what with this operands. Okay, and then after that we add it with this operand. So this is the most straightforward approach. You can forget about this approach, okay, and then what we have to do is just, if you remember, like we can use the whatever we can use 1-bit adder here, that is the 1-bit full adder, and we can cascade that full adder 4 times, similar to what I shown you in your lab software. Okay, so by doing that you're gonna get like a 4-bit full adder. Okay, and what we will do the same thing. So to calculate P0 is simply an AND between A0 and B0. That's it. I'm gonna get P0. Now here at this stage, what we're doing is we're adding, at this stage we're adding 1 2 3 and 1 2 3 4. Okay, so like here what we're gonna do is we're gonna use A1 B0. Look at this, A1 and B0 at our first operand to be like at x0, and A2 B0 here, it will be x1, as well as we will have uh, A3B0 and A3B0 to be to represent the 3rd bit. And look, we have nothing here, 0. So that's why at x3, at your parallel 4-bit adder, you're going to indicate 0. And since we're adding just 2 operands, we will indicate 0 at the carry in. Okay, for the second operand, okay, what you will have is to include all of these like this line. Okay guys, this line. So at y0 you should have a0 b1. Look at this, a0 and b1. Look at this, a0 and b1. And at this, the second bit, it has to be A1, B1. So that's why we have A1, B1. And then we have A2, B2. And here we have A2, B2. And then we have A3, B3. That's it, A3, B3. Now, the sum of between this and this, okay, we will use just this bit to indicate P1. That's why we use this bit to indicate the sum, to indicate P1 here, as you see that. And then after that, the sum will be used to be added with the third line here in the blue, okay, at this line. At this line, okay. So as you can see, we will add at the new x0 the sum that we calculated here between these two, and we're gonna add it with A0, B2. Look here. A0, B2 here at this gate. And S2 will be added to the A1, B2. That's it. A1 and B2. And so on. And at the end of that addition here, at this stage, I'm gonna get P2. That's why you look at the sum of the second parallel full adder here. I'm getting P2, and I can continue it. I hope that's clear for you guys, and I wish that's not like long for you. Have a nice day.